Hi everybody, welcome. This is CTD310, living on the edge. It's safer than you think. This is about building strong with Amazon CloudFront, AWS Shield, and AWS WAF. My name is Tom Whitman. I'm in our business development organization, and I'm joined with two of my colleagues today. One of our premier partners, Aether Suleiman, who is the co-founder and CEO of Flux7. And Sean Mark, who is our DDoS response team, one of our DDoS response team managers in Seattle. So we're really excited today to talk to you about this topic. And so we thank you for your time. What we're going to do here is we're going to cover a couple of things. I'm going to set some of the groundwork, and then Sean's going to walk into a little bit more of the details and the technical details. We're going to go through a little bit of a demo. And then Aether's going to give you some really good examples on how he and his team engage with customers to deploy some of the techniques that we're going to discuss today. A couple of the key points that we're going to go over is about architecting for resiliency, solving use case challenges, and really doing automation, the power of automation across all the different AWS services that are available, not just including the ones that we're talking about today, WAF and Shield and CloudFront, but also integrating Lambda and some of our other services. So first of all, just to get a groundwork on what is the Amazon Edge Network. Today it is a collection of edge locations that is primarily our content delivery network, which is CloudFront. We're at over 100 plus edge locations today and growing. Just a week ago we announced our 100th edge location in Tokyo. And then a couple days go by and another half dozen locations starting to lose count. So we can continue to build the network over time. So it's just going to continue getting bigger. At the edge, we have a number of different services. First and foremost is CloudFront, which is our CDN. And what the CloudFront Edge does is it has a bunch of caching servers that handle data egress, delivering content to end users that are requesting from your application, and also data ingress, put and post, patch, options, delete. All these methods are supported. In addition to the CloudFront Edge at the edge locations, in addition to CloudFront, we have our global DNS service, which is Amazon Route 53. We also have our AWS WAF, Layer 7 packet filtering service, the managed anti-DDoS service, AWS Shield, and our compute at the edge, which is Lambda at the edge. And so it's at every single one of these edge locations, and as we deploy new edge locations, if you're using these services, you automatically get these services extended globally. And it's these services that we're going to use in our examples today. So let's really quickly review CloudFront. So again, our global content delivery network, when we're talking about living on the edge and securing your applications, we consider CloudFront to be really a critical and core infrastructure component. Why? Because it helps you with application optimization and acceleration. It's a big distributed network, so you get to take advantage of the full network capabilities, the network effect, and the bandwidth that we've got available, and the routing that we've got available to you. You also get the advantage of caching cacheable content and proxy for non-cacheable dynamic type content. As with all of our services, on demand, full control, and cost effective. The web application firewall, again, our layer 7 packet filtering service, protecting against common web exploits. Many of you are concerned about making sure that your application is hardened. Doing so can be accomplished using the WAF. It's deployed again at all of our edge locations with flexible rule creation and the ability for you to write custom rules. Those rules then get deployed to each of our edge locations in under a minute. When the rules are implemented upon a request to CloudFront, typically the rule logic ends up happening in just a few milliseconds, so it adds almost zero latency or delay to your application and has a nice protection right up front. The AWS Shield Advanced service is our managed DDoS protection. The greatest thing about this service is that it's an inline DDoS protection. It requires no architectural changes. So you literally can just turn it on, select the CloudFront distribution that you want to protect, and immediately we start protecting from the network layer at layer 3 and layer 4. In addition to having the service turned on, You also get to benefit from additional visibility. You get a number of different CloudWatch metrics that are available to you, so you can see the type of attack, the nature of the attack, the length of the attack. You get a good visibility into what attacks are occurring within the entire AWS infrastructure, as well as what's happening in your environment. You also get access to Sean and his team, who runs the DDoS response team, a dedicated team that's really focused on DDoS attacks and can help you mitigate through the attack period. So from this point, I'm going to hand it over to Sean. He's going to walk through some of the architectural components that are necessary. And Sean, take it away.
All right. Testing. Okay, great. Thanks, Tom. All right, so we're going to jump right in. Bear with me. We'll get through a few slides, and then the fun part, I've got a demo prepared where we'll launch a synthetic attack against some resources that we've protected and see how some basic automations can start to play together and assist your operations teams in responding to those. So before we begin, I just want to kind of address, when we design solutions for our applications, there are a number of best practices that we like to follow. And I don't always see these as just goals that we work towards, but characteristics of the underlying components and the building blocks that we use, which is why for me as a security practitioner primarily focused on DDoS mitigation, scalability and automation are very important. So one of the most obvious ones is scalability. And the reason why CloudFront is very important or a critical piece of that design is because you may already be familiar with the regional architecture and the components and terminology, right? Availability zones, redundant paths to the internet exchanges, no single point of failure, and that's great. But CloudFront takes it to a whole nother level. The Edge Network has today 107 POPs, and you have to check that number almost every day, which actually are on internet exchange sites all over the world, in the eyeball networks, in the commercial exchanges, and we utilize both direct peering and transit services to bring Amazon and AWS customers content as close to the end users as possible. Intrinsic benefits for security, from a DDoS perspective, are that additional capacity is available, so you don't have to worry about saturating a regional finite amount of capacity because the attack will land closer to the source or origin of the attack. To illustrate that, this is a diagram of a typical region. I used US East 1 as an example. And I'm only showing a handful of internet exchanges or transit centers, but when you fold edge services into or on top of an application built into the region, it looks something like this. And so your attacks and your transit, or your attacks and your requests land closer to the customer, isolating things like state exhaustion and volumetric attacks further away from your resources. So let's take a look at a sample architecture. This is actually the architecture we're going to use in our demo in a little bit. It's just a simple WordPress site behind an application load balancer in US East 1. When you add CloudFront and Route 53 and WAF to the mix, no change is necessary to the regional architecture. It's plug and play. So what are some of the common challenges that we face when looking to implement something like CloudFront? Maybe you have a dynamic application, or your content is generated on the fly. Maybe it's a very interactive application, and you think, well, I'm not really caching. It's a zero cache scenario, or it's an API. That's fine. You can still benefit from the scale and security posture that's built into CloudFront and the Edge Network without even using the caching features. And I'll show you how to do that today as well. Perhaps you haven't decided not to use CloudFront yet, or you have an administrative constraint. That's okay. You can still set up a distribution, and because Amazon's pay-as-you-go model, you don't pay for it until you use it. So you can set up a distribution, have it on standby, use it in case of an emergency, or if you have a failure in some other component of your infrastructure, maybe an external DNS or external content delivery network, and it'll be there ready and waiting for you when you need it. So fun fact, you can actually use CloudFront to protect applications stored on and off of Amazon Web Services. Perhaps you have a hybrid environment or a multi-cloud strategy. You can use CloudFront or have it on standby to protect assets whether or not they're on AWS for both static and dynamic content. When you disable caching and you forward all requests through CloudFront, you effectively turn it into your own personal DDoS protection proxy on over 100 POPs worldwide. Now, this is something that was really neat. I'm not going to demo it today, but I wanted to share it with you. One of my customers recently had stood up a CloudFront distribution for assets that they didn't want protected full-time. But they were using CloudWatch to measure request rates and connection status of their load balancers, And when they exceeded a certain threshold, they would on-ramp to CloudFront during those peak times and off-ramp back to their application load balancer after that's ended. Okay, now the fun part. Everyone can see that? Okay. So we're going to jump right into the EC2 console. This is the instance where we're running our WordPress site. You can see I've associated or attached an elastic IP address to it. I'm going to test it right now. And we should get the landing page for your standard WordPress deployment. And it works. You can see there's one post or one blog with your basic comment. So we're going to proceed to lock that down. We're going to go over to CloudFront. Now, I already have a distribution set up. I set it up earlier this week, but I'm going to show you the steps that I took in order to get that deployed. We're going to get started for web, and we're going to choose the application load balancer as our origin. Now, there's a lot of options. I'm just going to focus on the ones needed to deploy CloudFront as a security component of your application, so just as a DDoS proxy. And so to do that, we're going to have to change a few options. One is we'll want to allow all HTTP methods, so your puts, patch, posts, deletes will still go through. And we'll want to cache based on all keys, right? Which essentially turns off caching. So there's nothing left to cache once you're forwarding query strings and cookies. So we'll need to forward all cookies. And cache and forward all for query strings. Now I'm going to jump down to the bottom here. I'm not going to show you how I did that in this demonstration, but I prepared a web ACL, which is one of the components of AWS WAF. In AWS WAF, you can create match conditions and structured objects that are part of rules, and those rules are compiled into web ACLs, which can then be associated with your assets like CloudFront distributions and ALB instances. So I'm going to associate this web ACL with our distribution. I'm going to click Create. So for the rest of the demo, I'm going to use this distribution here, ending in JU2. So let's go ahead and test it. Loads right up. And the web ACL is just a simple rule I wanted to demonstrate for blocking things like WP admin. This is the standard rejection page from AWS WAF on CloudFront, but you can use custom error pages and handle that differently. You can redirect to Lambda, you can redirect to a custom error page, revert them back to a landing page, anything you want. So now how do we protect this with AWS Shield Advanced? I'm actually really excited to show this. Most people have not seen the inside of Shield Advanced. If you're not familiar with AWS Shield, I urge you to attend one of our other talks tomorrow on Shield. It has 2 levels, standard and advanced. Every Amazon service is protected by Shield Standard, right? So out of the box, if you're on Amazon, you're using Shield. Shield Advanced is where you unlock additional visibility and mitigation capabilities by registering resources with Shield that will emit CloudWatch metrics as signals, so you can automate changes in your environment, notify your ops teams, and you'll get access to detailed reports, which is a new feature that came out last week. I'll show you that too. So this is the WAF dashboard. Now the first page on the Shield Advanced dashboard is a list of your protected resources. And you can see I have one here. I'm going to show you how to protect a resource. You choose the resource type first, and you can see that it supports CloudFront distributions, load balancers, classic load balancers, application load balancers, and just recently we added support for elastic IPs, and that's whether it's associated with an EC2 instance or even NLB. And I do have an elastic IP address behind this application load balancer, so I'm going to go ahead and associate that now just to show you. Now you can see that you'll get network layer visibility and mitigation, and that the web DDoS visibility is disabled because the resource type is a layer 3 resource type. If I were protecting a CloudFront distribution, this box would be checked. And I'll add that to the protection. So now the Shield service is going to start gathering telemetry against these resources, detecting known vectors and anomalies, and alerting you both through the console and through CloudWatch. Now I'm going to show you the attack details really quick. I had a SYN flood on this account that took place on the 28th. And when you click on the resource link, it takes you to the detailed attack details page. It'll show you the attack over time from beginning to end. the vector that it was detected on, the duration of the attack, and some of the top characteristics of the attack, sources by IP address, autonomous system number, and source IP. Now this is a really interesting feature. We just launched it at the beginning of November. It's called the Global Threat Environment Dashboard. And as a Shield Advanced customer, you'll be able to actually see the threat landscape across all of AWS. This is a snapshot in time. It's updated in near real time. And it shows you the threats that are landing on the AWS network fabrics, both in the regions and on the border. There's a little heat map that kind of gives you a sense of where most of them are landing, some of the top metrics, a histogram over the last day, 3 days, or 14 days, depending on the view you select. And then by unit, packets per second, gigabits per second, and requests per second, what Shield is seeing. This might be useful if you're making decisions about where to scale out during a surge event, like a promotion, or you have something that happens on an annual basis, a large sale, you want to choose which resources to use. Do we want to use an ALB in US East or US West? Do we want to move to CloudFront or stay in the region? It also helps you just get a sense of what's going on in the environment. So what I'm going to do now is I'm going to launch a synthetic attack against this CloudFront distribution, which will trigger a few alarms, and I'll walk you through what that looks like. While I'm doing that, Tom's going to go over a few things with some of the automation options, with how you can engage the DRT team and use this signaling.
All right, so this was what I was talking about by extending the Edge services into some of the AWS services. With AWS Lambda and with CloudWatch and these CloudWatch events, what you can do is you can trigger an event to trigger off a Lambda, and that Lambda can then fire off notifications to contact the DDoS response team. Maybe you want to add an additional resource into the protection set. Maybe you want to update or change one of the rules or conditions within the web ACL that you've got associated with the resource. What we've done here, and we made available to some of our DDoS, our AWS Shield Advanced customers, is we created a AWS IoT button. And that IoT button is AWS Shield branded IoT button. And what happens here is that we've created a Lambda that we maintain. And when you're experiencing some kind of an attack, or if you need help from the DDoS response team and you're a Shield Advanced customer, you simply press the button and we automatically open up a ticket with the DDoS response team, and they're immediately starting to work on your case. They'll see the case come up in their queue. They will be able to reach out to you and talk to you about what's happening, either if it's in response to an incident or if you just need help because you're stuck or you need to verify or validate some of the mitigations that you're putting in place, or maybe you've received a threat about a potential attack and you want to make sure that you're prepared and ready. Press that button, it's kind of like breaking glass. The cool thing is it's not just about the button though, it's really about the Lambda code that's sitting behind it. You can take that Lambda code and implement it within your own application, and you don't necessarily have to have this as the trigger, you can have the trigger anywhere in the environment. We actually did another talk where we have a customer, a gaming customer, that we gave these to, and during a particular event that they had, this was a very important thing for them to have. They thought it was not only a kind of a cool factor, but it really helped their team actually mitigate and think a little bit differently about how you can use different services within AWS to integrate.
Thanks, Tom.
Yep.
That bought me a little time to launch the attack. So you can see now that the attack is ongoing, you'll get an alarm in the Shield console, which generates a CloudWatch metric, and we'll look at that. It says you have one ongoing attack. And you get an alert, a notification down here under incidents. And you can see that there are 2 ongoing attacks. I actually launched one against each of the distributions, the one I created just now and the standby one. And if I click on the metric, should be about 10 gigs of UDP traffic. And there it is, there's our single data point. And over time, this metric will collect more data. And if additional vectors are found, then you can add those metrics to your dashboard. So maybe you have a per resource dashboard to show production in US East, and you've got your request rate on one chart. You can potentially have all of your metrics on another chart. And there's 2 types of metrics. There's DDoS attack detected per resource, and then there's the per vector dimensional metrics. The per resource metrics are really great for a signal to engage your ops team or to just have an alarm there is an attack. And the other metrics, the per vector stuff, is better for forensics, deep diving and figuring out exactly what's going on, helping you to, and those can be really helpful for making architecture decisions. Oh, we have a SYN flood against the server directly. We need to put something in between it that handles state for us, like ELB or ALB or CloudFront.
Sean, since there's an attack, I'm going to go ahead and press the button.
Go for it.
All right, so what I'm going to do is, because there's an attack, I'm just going to press the button. And right now it's registering with the connection. And as soon as it finishes, it goes green. And now I've executed the Lambda code to say, hey, DRT, I need some help.
Yep. So this isn't an AWS service, but it is some Lambda code that we share with our customers for Shield Advanced or Shield Standard customers who want a programmatic way to engage the DDoS response team. So that Lambda function does two things. It's associated with my demo account. It's going to open a support case and say, I'm under DDoS, please help. And it's also going to talk to an SNS topic that my team owns, so we can kind of preempt support and engage you directly. We'll open up a chime bridge with you and work with you on your attack as it's going. So you can see that the alarm is now in an alarm state. And this is just signaled off of the DDoS detected attack. And since Tom pressed the button, two things are going to happen. If I go to the support center for this account, you'll see there's a new support ticket that's been opened right here. It's unassigned. Now, the support level on this demo account is just business, and I think I've even flagged it as internal, so I'm not going to bother any reps. But you can see immediate DDoS attack detected, assistance requested, and there's a whole canned response in there. What's also interesting is it'll actually page my team.
It works.
Not me, but. And so that's one of probably the most common and simple ways that you can start to automate and use AWS services and integrate them together with edge services like CloudFront and WAF and Shield Advanced, and they all start to come together. If there's one takeaway point I would leave you with, it's that CloudFront really is probably the best way to get the most mileage out of your architecture and improving your security posture with regards to DDoS protection. And at this point, I'm going to hand things over to Aether, one of our partners, who's doing even more advanced and interesting things with WAF integration. Thank you.
Thank you, Tom and Sean, for the opportunity to have me come up here. And it's really difficult to go after you guys. That was a fantastic demo, by the way. So just a quick introduction about my company, Flex7. I'm the CEO and co-founder of Flex7. We are a premier tier AWS partner. Some other awards and accolades that we have received. 4-year-old company headquartered in Austin, Texas. And a couple of things I want you to note. One is our DevOps competency. I'll speak to that a little more, but Flex7 has a very strong focus on automation and being able to speed up the time to market while keeping things secure. And that's where the edge services, as well as specifically the AWS WAF, comes into the picture for us, and I'll speak to a couple of case studies. Other things you will notice, we have a healthcare competency. We do a lot of work with healthcare, financial services, so mostly high compliance environments, again, where people want to reduce time to market, but also maintain security and compliance as they go through that process. And we also service delivery partners with CloudFront, AWS WAF, which is what I'm going to be covering today. So before I go too far, I want to just share kind of my worldview, because I think it's important to get the biases out of the way first. So when we look at things from the Flex7 perspective, personally, big fan of doing everything in a software-defined fashion, infrastructure as code. So we are big-time users of CloudFormation. We are very big on configuration management, taking advantage of services like Lambda, to automate whatever we can when it comes to operations. And the idea is to treat infrastructure and server configuration very similar to how we treat code. What that means is you need continuous integration and delivery of infrastructure, continuous integration and delivery of server configuration. And rather than your inspection or reviews of your infrastructure and configuration being a manual process, turn them also into automated code reviews, just like you would actually do, just like you would do with your application code. And at the helm of all of this is that landing zone piece that you see at the bottom, which is basically the platform where when we automate all of this is supposed to land. For us, that platform is AWS, and we take advantage of AWS services to make all of the above possible, which is the implementation of these automated pipelines, what we call injectors, for example, secret management, or inspectors, for example, things like WAF, CloudFront, CloudTrail, etc. When we are working with our customers, the goal is, as we often describe it, is to build them a highway on which they can start to innovate quickly with their solutions. When you typically work with us, it's a complete people, process, technology package. So from the people side, there is coaching involved in helping you build a center of excellence. On the process side, there's a lot of process automation and integration of different components. And on the technology side, there are several components that need to be put in place to achieve that goal, where you get agility while maintaining security and compliance. So what it boils down to is several elements, including a business case, a roadmap, building a center of excellence, setting up your AWS landing zone correctly, and that's where, for example, AWS WAF comes in, because it's an important element of protecting things at the edge, building some technology-enabled pipelines, setting up monitoring, logging, that's just rather standard stuff. And I think one thing worth noting that we firmly believe as a company that at the end of the day, agility really comes from when enterprises or organizations are able to do stuff themselves rather than having somebody else do it for them. So at the end of the day, it's about the transformation and it's about the coaching, which is why I say when we talk about applications, we are talking about working examples, not necessarily doing it for our customers, but rather coaching while doing the work so that we do 1 or 2 examples and then the customers take it from there and run with it. And that also includes a catalog of templates and libraries, very typical for us to build libraries and templates that would include things like CloudFront, Route 53, so that our customers and different application teams at the customers can take advantage of those. So with that, I'll actually just present one of our customer stories. The customer is TN Marketing. They go under a brand name of Vidstore. Marketing and advertising company. And the challenge that Vidstore was facing was that they wanted more visibility, more situational awareness as to what was happening in their infrastructure. And it's an environment which is actually handling a lot of sensitive and private data. So there was a need to ensure security and high availability, a very high uptime, while streaming video to their customers. Vidstore, just to be clear, as the name suggests, is a video on demand where you can actually buy videos and stream. When it comes to the solution, there's a lot of AWS services that came into play. So we were taking advantage of EC2, obviously. Auto-scaling, taking advantage of the load balancer, doing the typical security stuff with regards to the VPC and setting all of that up. But I want to jump to the more interesting components, which was how do you actually do caching at the edge using CloudFront to be able to deliver the content closest to the customer and reduce the latency for them. And the second part of that was how do we actually secure at the edge so that the sensitive data does not leak if they are ever under an attack. So without further ado, let's talk a little bit about the architecture. As I mentioned, this one's from an application architecture standpoint, just note that there is a VPC, a multi-availability zone architecture with an ELB in the public subnet, kind of the standard stuff that you would expect. A couple of load balancers, an application tier, some databases, and a caching tier. But what's more interesting in the context of this talk is what is outside the VPC, which is you have your AWS CloudFront distributions, and Sean kind of walked you through on how to build one of your own, and how the CloudFront distribution is actually tied into the AWS WAF. So the idea is that when your customers are actually trying to access the web service, the first thing they're actually hitting is the Amazon CloudFront, which is at the edge. CloudFront consults with the WAF to decide whether or not the request is to be serviced. After making that decision, CloudFront will service it either at the edge if it's a cached content. Otherwise, it will forward that request over to the load balancer where the application servers can go ahead and service this request. And what this allowed the customer to do was, and I'll get into the details of what we did at the WAF here in a second, but the idea is that it's allowed us to achieve scales, reduce latency, and increase security all at the same time by having this very simple design, thanks to the managed services, very easy to set up, very easy to get going, and I'll actually talk about specifically that piece around CloudFormation here. You might notice in the icons below that there's a CloudFormation icon there. Ties it all back to my bias I mentioned earlier. Big fans of being able to automate things and create them in a software-defined fashion. And this is what AWS CloudFront and WAF enables us to do, which is we can actually provision that entire infrastructure that you see on the screen with a single click, if you will, with a single CloudFormation template, creating stuff at the edge, creating what's in the VPC, creating the CDN, all of that under one roof with a single CloudFormation template. And that's the automation benefit. And it actually goes beyond that. It's not just about configuring CloudFront or spinning up a WAF. It goes beyond that because CloudFormation allows us to even create what, as Sean was talking about earlier, the ACLs and then we can actually create IP sets and further rules underneath it that would actually, essentially when you're creating the website with that, all of the security at the edge is being defined as code as well, which goes very well with our preference, and that's why at Flex 7, we are big fans of taking advantage of it. And just to kind of sum it up, I think one small way to think about it is that pretty much everything that Sean showed in his demo, which he was building up from the console with respect to the forms and how to make all those choices, we can take all of that and just put it in a YAML file and just run it through CloudFormation and have it all be created with a single click. Another story I want to talk about is Rent-A-Center. If any of you was at the Global Partner Summit yesterday, Rent-A-Center was mentioned during the keynote and some of the work that we did there. So this particular project at Rent-A-Center was about taking their e-commerce platform and moving it into AWS. The platform of choice in this case was SAP Hybris, which is actually a very common choice for e-commerce platform by our customers. But what was interesting was the way Rent-A-Center wanted to approach this problem. The goal was not just to have it in the cloud or sort of do a lift and shift. Instead, they really wanted to treat SAP Hybris more like a cloud-native application. And while we do not have access to or the ability to change the SAP Hybris code, the challenge was, can we put SAP Hybris in a framework which works very much like a cloud-native application? What does that mean? SAP Hybris was containerized in Docker containers. It was deployed on top of Amazon ECS. It was taking advantage of the Amazon Elastic Load Balancer. It was taking advantage of Aurora. It was taking advantage of CloudFront. It was taking advantage of the WAF S3, and so on and so forth. And all of this was done with the goal to minimize maintenance, maximize agility, and now the third factor is how do you actually maximize security, because this is an e-commerce platform and it actually has to undergo PCI compliance audits at some point. So the idea was, well, putting it all together, can we actually build an environment which has very high agility and able to take, is very low maintenance, has PCI-grade security, and just jump into the solution. I think the most interesting part of this project was how do you take Hybris and put it inside containers, because Hybris is not an application that was written with a cattle mentality. It's a very pet-like mentality where servers are supposed to be static with fixed IP addresses. That was a whole interesting part of the challenge itself. If any of you are interested, you can look up a talk that Rent-A-Center gave at last reInvent, talking about specifically that side of the challenge. I'm actually going to focus more on what's outside the VPC on this diagram again, which is there are actually 3 different edge services, as you can see, being used here. So one of the things with Rent-A-Center was, which was a very interesting goal for this project, was they wanted it 100% under the AWS roof, no other vendors involved. So the DNS provider is in there. They were actually using the Amazon Certificate Manager, so SSL was being managed by Amazon. the databases, everything from the edge all the way into the database, every single element is an AWS service. So for that matter, the users, when you hit the Rent-A-Center e-commerce platform, the first thing you actually hit is Route 53 for your DNS resolution. From there, it actually goes to CloudFront, which is a CloudFront distribution, caching at the edge the static elements of the e-commerce platform. Anything that's dynamic is actually passed through over to the load balancer. And anything that's static is actually being referenced over to an Amazon S3 bucket. Similar to the previous story, CloudFront is consulting with WAF along the way to decide whether or not a particular service is to be, a particular request is to be serviced. And just to give you a glimpse, inside that VPC, what you see is a load balancer, which is actually hitting the EC2 container service, ECS, the service, which I guess as we learned today in the keynote, sounds like there are 2 new solutions. So I wonder what the solution will evolve to with EKS in play and also the fully managed container service. But at the moment, it runs with ECS and then Aurora as the background database. Again, just for completeness, everything that you see in this picture deployed with 1 click, taking advantage of AWS CloudFormation. Now, let's talk about what actually happens inside the WAF, because we are talking about high compliance environments. We are talking about PCI. We are talking about these varied applications, some that are written by third party, other that are developed in-house. And one of my favorite features about the AWS WAF specifically is the customizability that it brings to the table. It gives you the power to define rules all on the fly based on dynamically what things are actually happening. And more interestingly, you get to define what that loop looks like. So we'll go through a couple of very simple examples. These are typical things that you would deploy if you are trying to build a PCI environment or a HIPAA environment. At the edge, you want to have these rules in the WAF. So, and just to be clear, there are WAF rules. WAF actually has these ACLs. Inside the ACLs, we get to define which requests go and which requests do not go. What I'm talking about here is a more advanced version of that, where we do not define the ACLs statically. That's why we are calling it the dynamic rules. The ACLs themselves actually get computed, if you will, on the fly and get created based on how your site is being accessed or based on other information sources that do get updated on the internet periodically. So my first example here is the Tor blocking. For those unfamiliar with Tor, it's basically a separate network, which I don't know much about. At least I'll claim that, of course, while I'm on stage. But it's the Tor network. It's a network that kind of built on top of the internet, very focused on anonymity of use. There are IP addresses through which people running in the Tor network can actually access the general internet, if you will. It's like the gateways from out of Tor into the regular internet. And there's a project called the Tor project, where one of the things that they publish is this list of exit addresses. Those are the addresses through which somebody from Tor can actually get access out to the regular internet. Since that's kind of the purpose of Tor, which is anonymity, it's a general assumption from the security community that you do want to block those exit addresses on your website. Now, this can be done with a static firewall where I blacklist IP addresses. The challenge with that is that this exit IP list actually changes very frequently by design. So a static rule set is not going to cut it. You have to have a mechanism that dynamically does it. Now, we could make it somebody's job to continue to look at this and continue to change the firewall rules. It's clearly not very efficient, and that's where the automation piece comes in. So what I show here to the right is a very simple architecture. Kind of what you see at the top is just a very standard, pretty much what we saw earlier, users hitting CloudFront passing on to the load balancer. And actually, to be accurate, while both examples I showed used CloudFront consulting the WAF and then pushing traffic to the load balancer, you can actually have the WAF directly working with the load balancer as well, with the new application load balancer. But that said, we'll go with this picture. Users are hitting CloudFront, and then from CloudFront, we actually, CloudFront consults with WAF to decide whether a request is a go or a no-go. So how do those ACLs actually get created? Well, they're not going to be created statically. So these are not ACLs that will get created through CloudFormation. These are not things that get created at the time you're provisioning. They will get created dynamically. So it's a pretty simple process at the face of it. What we really have is we would set up a CloudWatch event that would periodically trigger the Lambda function. Whenever that Lambda function triggers, what the Lambda function does is it reaches out to the Tor project website and downloads the exit address list. After that, it processes it, and we'll actually deep dive into the code in a second. It actually, from there, determines what ACLs need to be created to block those exit addresses, and then updates the WAF such that the WAF can begin to block those addresses. So that way, there are no human delays. This is going on 24/7 in the background. You're constantly getting you're constantly able to block those known rogue IP addresses. So just deep diving into the Lambda function itself, mainly just to show you a couple of things. One, how much you can customize. And two, just to give you an example that you can play with or get started with. This is an open source example that you can actually get your hands dirty with very easily. So we'll just dive into this Lambda function. So what does it actually look like when you download the exit address list from the Tor project? This is what a single entry looks like. About the node, there are certain information, status updates, what is published. Most important to us is that last line, which actually says exit address, then there's an IP address, and then there's the time next to it. So that's kind of our target right there, that 162.247 IP. That's the one that we need to find a way to block. And the file that you download contains tens and tens of these lists, these entries, one for each node. So I won't bore you with every single line of code, but I did want to show some of the most important elements of the code. And down below is the link that you can use to access the entire code. So when we're doing Tor blocking, this is just a Lambda function. Remember, this just gets triggered from time to time. What it's basically doing is there is one of the first things that you would expect. It's executing code to fetch the URL. That's what gets us that exit list. The exit address list. After that, it's if you look at the entire code, it's really just a simple loop where it's going line by line and running this regular expression. The regular expression is a relatively standard one, which is looking for IP addresses in each line of, which is looking for lines starting with exit address and looking for fetching out the IP addresses out of this. Each time we find an IP address, we add it to our list of addresses. There is just one more step that you have to do that I do not show in here, just to be able to fit this on one slide. But just worth noting that as we create these address lists and ACLs, and we create IP sets, as we call them, your individual CIDRs that you block, there are some restrictions on that. So those can only be either a /8 or a /16 or a /24 or a /32. So what that means is that if you want to block a range of IPs that is not a /8, /16, or /32, or a /24, you'll actually have to break it down. Again, it's an open source piece of code which does that job pretty well, which can take a bigger CIDR range and break it down into CIDR ranges of one of the 4 acceptable sizes. And then after that, once it takes those exit addresses and has actually come up with the final lists that need to be blocked, there's just one more step left, which is to merge this list with the IPs that you have already blocked. That's just a very simple step in the sense that if I've already blocked a particular IP address and it's still on the exit list, which is a very common case, I cannot go back and block it a second time. I just only count the new addresses, the ones that have just been added, and similarly look at the things that have actually been removed. Once all of that is set, the WAF API or the Amazon SDK, in this case, this is the JavaScript one. The JavaScript SDK allows for us to be able to update the IP set of of a WAF rule with a single line of code, and that's what you basically see on the screen. Just run, your WAF rule has been created. You can run this Lambda function. You can control the frequency at which this Lambda function runs through the CloudWatch events. You can run it as frequently as you like or as sparsely as you like. And it just, the pattern is the main thing to see here. While this works with just the exit addresses list from the Tor project, the idea is that you can have any reputation list. You can create your own list in which you can put sided ranges that you want to block, and just point that same Lambda function at your list, and it will be able to take it from there. And continue to, and as you will update that list, it will continue to implement those rules for you. And I think the last thing, the cherry on the cake here, if you will, that the provisioning of the Lambda function and the CloudWatch events itself is done through the same CloudFormation template as well. So when you run the CloudFormation template, you're not only getting the CloudFront, the WAF, you're also getting all these dynamic rules that are actually a part of the same package that you want to deploy. So you can really recreate production disaster recovery in a matter of minutes, including not just the operational elements, but also the security elements. Let's look at one more example, because this one's a little more dynamic, if you will, in nature. In the previous example, we were consuming a reputation list that was coming in from a third party. In this case, we are sort of making our own assessment and making a list of IP addresses that you want to block based on the user behavior that they're exhibiting while they're trying to access your website. So I'll start with a very simple example of this first. So let's say you want to do a simple rate-based blocking. By the way, rate-based blocking is actually a feature in WAF natively as well that you can use, but it's actually a great example to demonstrate what you can do. And there are several variations of this that you can create. If you want something more customized, you could actually write your own Lambda function and make it behave exactly the way you want it to behave. So in this case, it's a complete loop, if you will, as you can kind of see from the picture. Notice how there is an arrow going out from the CloudFront icon this time to an S3 bucket. What's going on here is your users are coming in and hitting CloudFront. Every access is generating a log entry in CloudFront logs, and CloudFront is writing those logs to S3. This is your record of what are all the events basically happening at the edge, all the users that are trying to come in to your website. All of that is getting logged. Now what we do is, to complete this loop, we actually write a Lambda function, and we trigger that Lambda function when the log is written. And what that Lambda function does is it actually passes the log, looks for certain usage patterns that we know are going to be suspicious, and goes ahead and creates a WAF rule on the fly to block those IP addresses for a certain period of time. In fact, other than the rate example, just to tie it back to something that Sean demonstrated earlier, that rule with WP admin, a couple of years ago, we were actually dealing with a customer where they were under a denial of service attack, and what the usage pattern was, it was a distributed denial of service attack, many folks trying to get in, many different IP addresses trying to get in, but it was a very easy one to identify, which is all of them were trying to hit the WP admin. It was also a WordPress site. So they were all trying to hit WP admin question mark and trying to do pass very lengthy parameters, trying to create some kind of a buffer overflow on the website. And very easy to block, which is if I were to create a dynamic rule for that, what I could do is, if in my log I see that a specific IP address has tried to hit WP admin 20 times in the last 30 seconds, there is something suspicious going on. I want to just block that IP address for the next 24 hours. That's the concept of dynamic rules and how you can actually block things based on what users are doing. So just to go a little deep into this Lambda function. So this is what a request looks like. I just have a couple of examples. The first request on the top is a request from a web browser. When the web browser makes that request, this is the exact line of text that gets written to S3 and as a part of the CloudFront log. There are several elements to it. I'll just draw your attention to the piece in yellow in the middle. That's your source IP address. And in this example, we are going to go a very simple rate-based we're going to do a very simple weight-based check here, which is that if a particular IP address tries to hit our website, tries to access our website, say 1,000 times within a minute, there's something suspicious going on. We're actually going to go ahead and block that IP address. So this is what the log looks like. Pretty simple piece of text. The IP address is right there in the middle as a token. And what our Lambda function does is as follows, which is actually goes through the log file. And for each record in the log, it basically tries to count how many times did that particular IP address access the website in a given minute. So let's just say that the log contains entries for the last 2 minutes. Then it will say that IP address A accessed it 500 times in minute 1 and 300 times in minute 2. So it's able to construct a very simple map of, for each given source IP, for each given minute under consideration, how many times did that IP address access? And it's doing through by just going through simple text parsing, something you could actually write in as a bash script in a single line, literally. And then it's, again, very intuitive, very simple. You go through each source IP and just compare the access rate that they have had to whatever your threshold that you want it to be. Say my threshold is that I'm going to block anything that tries to access over 1,000 times a minute, then that's my threshold, which you may notice is actually a parameter to the Lambda function. Based on that threshold, it decides which IP addresses or the source IP addresses are to be added to a block list. And then after that, we pretty much see the same piece of code that we saw earlier. It creates a list of IP addresses to block and runs that very last line, which is using the JavaScript SDK. Well, actually, sorry. In this case, it's Python. Using the Python Amazon SDK, it's going ahead and calling the WAF API and updating the rule set. Now, what this does is this has actually blocked that malicious IP address that had a rate of access that was above a certain threshold. So it can be used to block something like a denial of service attack. And again, keep that other example I gave you with WP admin in mind, because that's the idea. If you see specific patterns, you can customize your Lambda. This is an open source Lambda function. Again, the code is at the bottom. You can take this and develop things that are very customized to your own application. It doesn't have to be generic. And that's the idea of DevOps Sec, essentially. In fact, one conversation comes to mind that I was having very recently with a dev team and a sec team concurrently, where they were talking about incident response. And one of the discussions that came up was, well, what happens if we have a known vulnerability in a third-party application that we are running, but we do not have the time to upgrade it right now because we are under a situation where we cannot bring the application down. This was for a very large marketing site, one of the largest marketing companies in the world, actually. And the simple answer was, well, if your developers understand what the vulnerability is and how can a user exploit it, just write your own Lambda function to block any IP address that tries to exploit that vulnerability. And you can buy yourself some additional time before you have to upgrade the application immediately. So that's where I think it kind of comes together to what I said earlier. It's about being able to provide security and agility at the same time. So just in summary, a few things I want to touch on. One, we have actually found the AWS solution, the WAF, to be very versatile. As a consulting company, we have worked with other WAF vendors in the past. That the versatility and the flexibility has been commendable. It's been, that's why it's been a very highly recommended tool of ours. The automated provisioning, I have given you several examples, I cannot overstate the importance of this capability that you can put your security fabric. It kind of encourages that security by design approach from day one, because you put your security fabric is interweaved with your ops and your dev fabric. It's not this thing that you're going to come back and put to the side. It's really a part of everything else that you're doing from day one. Very customizable through Lambda, and we saw a couple of examples of that. The ability to create these rules on the fly, and whatever rule you want on the fly, because it's just code, is very powerful. There is a body of knowledge that already exists. For example, AWS has graciously open sourced several of these dynamic rules that you can access and start playing with yourself. There is an ecosystem of partners like ourselves who can actually help you write your custom rules that you need and actually manage them for you. And over time, again, to my point earlier, the idea is to bring the DevOps sec together and within the company developing those skills as well so that you can actually identify exactly the rules you need. And this gives you the capability to do it all yourself if that's the model you want to take. And that's basically why I feel that the tool actually gives us a lot of capability for doing DevOpsSec in a true sense, stated with a couple of examples. So with that, I'll pass it back on to Tom.
Great. Thanks very much, Ed.
Time.
All right, so hopefully you found this presentation helpful. Just to sum up a couple of the things, there's a number of different elements that make living on the edge or implementing an edge infrastructure a really critical component of your application architecture. One is you saw CloudFront, whether you're using for static assets or dynamic assets, using it for a proxy into for a protection mechanism for layer 3, 4 using our managed anti-DDoS service or using the WAF and the automation that goes along with it. Integrating with the AWS WAF and pushing those web ACLs and the rules and the conditions that get implemented right at the edge, or using the inline DDoS protection service at the edge makes your application a little bit stronger in terms of having a more hardened security posture and really limits the size of the attack vulnerabilities that may be existing for you. So hopefully you can get started with this, or you feel that you have enough knowledge now to get started with it. You can set up a CloudFront distribution, again, without even having to pay for that distribution. You only pay for it when you're actually using it, so you can set it up. You can start to create that perimeter protection around the application, so you have your boundary, and only when you want to turn it on and start using it will you start actually paying for the individual services. So that's it for our presentation today. Hopefully you found that helpful. We will be available for a few minutes on the side of the stage, and we do appreciate your time today, and hope you have a great reInvent.